So we're really getting into the heart of all of this today and making sure that we can put it all together with A, B, H, and K. Word problem-y stuff, modeling that periodic behavior with sinusoids, not today. We won't get there. But let's see, I think we were on problem number, 7. I remember the notes were here on Friday. So I stopped at B. It just seemed like we weren't really getting to the heart of what you were going to have to do in your homework by just doing some of the easier and more basic ones. And now C, definitely, B started it, but C starts us thinking more about what happens when the period changes and you have a phase shift and how all of that comes together. So this is example 7, and it is part C. Well, here we go. We know the amplitude is a 4. That's right in front. And the instructions way up at the top say determine the amplitude, the period. And to figure out what the period is, I have to notice that there's a 2 right here. And I recognize that I can't talk about what the phase shift is going to be while that 2 is still attached to that x. So I have to factor that out. So I have to think for a second, okay, well, factoring out a 2 is like dividing things by 2, but I have a fraction back there. So you wouldn't divide by 2, you'd multiply by the reciprocal, which is 1/2. So your denominator would increase to a 6 to make that happen. And then you can just think backwards for a second. That would be 2 pi over 6. Oh yeah, that would go ahead and reduce down to pi over 3. So the period for this is 2 pi over the absolute value of b. And we now see that b is going to be 2, which gives us a period of pi. And I can't help it. I start thinking about how, okay, 1/4 of that would be pi over 4, because to find our nice little intervals that we need, we're going to need that information. So I'll write that down. But now comes the phase shift. And the phase shift is the part that tells us basically we have a new starting place for this graph. So we have a phase shift of, and then we remember everything with x is the opposite of what we see. So this wonderful little 2 that we saw in front is actually a horizontal compression factor of 1/2, and our phase shift is pi over 6 to the right. So now comes the bulk of the work. And let's go ahead and label our y-axis before we have to get too carried away with the x's. We know this is going to have to go up and down 4 units for the amplitude, so I think sticking with 1s would be a good idea. And to start my graph, I need to know, well, where's the starting and stopping point? I already know what I should be using for intervals. That should be pi over 4 for the length of the intervals. But to figure that out, we'd say, well, normally our period, which is what we look at horizontally, is going to be from 0 to 2 pi. But that's not just x in this one. There's a lot more going on than just x. So in between those two, we have 2x minus pi over 3. And what we want to do is solve that inequality so that we can see, hey, this is what my x's should be now as I go after this. So we would add pi over 3 to all 3 pieces. And so if you had 2 pi plus pi over 3, you'd have to do your common denominators. And think of 2 pi as 6 pi over 3, plus another pi over 3 would be 7 pi over 3. And then again, we're dealing with fractions, so I know we think divide by 2, but you really should think of it as multiplying by 1/2. So we're going to go from, oh, that's a little hard to read. Pi over 6 to 7 pi over 6. But I still don't know how that labeling of the intervals is going to go, because I realized that I had to split my period up into pi over 4 to find my intervals. So this is a good starting place, because this tells me I'm going to start at pi over 6, which we knew anyway because this had that phase shift to the right of pi over 6. But we'll start there. That'll be our starting place on the x's. And we know we have to add pi over 4. And of course, at this point, we realize, okay, we're going to be doing a lot of common denominator stuff here. So 6 and 4, least common denominator would be 12. This one will need a 2 on the top and the bottom. And this one will need a 3. And after you do a couple of them, you probably won't need to write all that down anymore. But this would be 2 pi over 12 plus 3 pi over 12, which is 5 pi over 12. Then we have to add another pi over 4. And again, we already wrote it down over here. We know that's going to be 3 pi over 12. So that'll give us 8 pi over 12, which will reduce to 8 pi over 12. You could put a 4 into both of those. So we had 8 pi over 12. We have to add another 3 pi over 12 and get 11 pi over 12. We add another pi over 4. Well, again, that's 3 pi over 12, so that'll be 14 pi over 12. And I realize, excellent, that matches up. I was supposed to end at 7 pi over 6. So I'm reducing them as I write them down. You wouldn't have to do that. You could wait until you put it on your x's. If that's slowing you down because you're like, oh my gosh, I have to sit here and reduce all of these, then write them down as 8 pi over 12 and wait until you put them up on your axes before you change that. But here's the big deal. At some point you want to say, what do I have here for my biggest denominator? Because that's how I'm going to have to label these, or I'm going to distort the graph. I want to make sure everything fits on here like it's supposed to. So my biggest denominator here is a 12, which means I'm going to have to use pi over 12 as my guide for how I'm going to graph this. But let's take a peek and see if it'll work out nice. So 1 pi over 12, 2 pi over 12, which of course reduces to pi over 6. So maybe this will work out decent anyway. 3 pi over 12, 4 pi over 12, 5 pi over 12. So it looks like it's going to work out spacing-wise anyway. 6, 7, 8 pi over 12. Well, that one was our 2 pi over 3. 9, 10, 11 pi over 12. I want you to take a look at where my hash marks are. Do you see how that shows what the spacing has to be for each set that we've done? So each one of these, to get the nice numbers that we had when we figured out pi over 4 as our intervals, is showing us that we're going to have to go 3 blocks here. 1, 2, 3. Negative pi over 12 to go to the left. And you may have realized, Cedarholm, you couldn't get the whole thing on there. You know, you didn't get the 7 pi over 6. Well, you'll notice in the instructions up there, it doesn't say graph 2 full periods, because often we can't, not without squishing things, you know. So we're just going to fit what we can in there. So we have to go 1, 2, 3 more of these. So 1 pi over 12, 2 pi over 12, 3 pi over 12, 4 pi over 12, and 4 pi over 12 would reduce to a negative pi over 3. 5, 6, 7, negative 7 pi over 12. 8, 9, 10, negative 10 pi over 12, which reduced to negative 5 pi over 6. and then I won't be able to get to another one on the other side. So on Friday, the big thing that, like I said, I kind of went like 6 minutes over on the video. The big thing I wanted to get to was it's okay to put helpers on these. Because what sometimes happens with this is we go, okay, now I'm ready for cosine, so I can start up at 1 and somebody accidentally starts up here, you know. We have to put a helper in. That's where that other color comes into play. I want to mark, where am I supposed to start now? And I know I was supposed to start at pi over 6 because this was a phase shift. But just like you learned in Algebra 2, helper lines are never solid. Never. We talked about that when we were doing our asymptotes earlier this year. So dashed, dotted, whatever you need, but that's going to help so that you don't accidentally start in a place that you shouldn't be starting. Alrighty, this is cosine, Kahala. Cosine starts high, but our amplitude was 4. So right here, I have to go up 1, 2, 3, 4. Kahala. Cosine is high, axis, low, axis, and then of course high, which we can't fit on that one because we didn't have enough space for 2 full periods. But you can follow that pattern backwards. So again, there are times when we can't fit 2 full periods, and that's why the instructions change for us there, because we knew we couldn't fit 2 full periods on there. If we do a good job of spacing it out, we're not going to be able to do that. So when you get to the point where you see all your values, look for that largest denominator that you have, because that's going to be your guide as to how you have to use this so that you're not accidentally crunching part of the graph that shouldn't be crunched. Compressing it. All right, then we do everything. Amplitude, period, phase shift, graph. Got it. Let's go to the next one. For sine of the quantity 2x minus 2 pi over 3. Starting with the amplitude. So again, we have a 4. 2 pi over the absolute value of b is the period. And this is where I realize, oh gosh, I'm going to have to factor this one now too. So again, think of factoring out that 2 as if it were dividing by 2, which is multiplying by 1/2. So this would be, the 2's would cancel, we'd get a pi over 3 up there. And you could distribute it to make sure it's going to work. This would definitely be 2x minus 2 pi over 3 when we put that all together. All right, so 2 pi over 2. Once again, we get pi for the period. And once again, I'm thinking about how I'm going to have to use that pi over 4 for the size of my intervals. But I want to know where to start. I mean, it's pretty obviously we're going to start at pi over 3, but start and finish so that we know we're doing this right. And again, the period for sine is from 0 to 2 pi. But that's when it's just an x in the middle. It was not just an x. It was 2x minus 2 pi over 3. So we're going to have to add 2 pi over 3 to all 3 pieces of our inequality. Since it's over 3, again, think of your 2 pi as 6 pi over 3. Kind of nice how they both ended up that way. And 6 pi over 3 plus 2 pi over 3 would be 8 pi over 3. Still have to divide everything by 2, which means multiplying everything by 1/2. And here our 2's would cancel out. So we would get pi over 3. And back here, you either do a little canceling, reducing first, but you can do 8 pi over 6 and then reduce it to 4 pi over 3, however you want to do it. But that gives us a really good check that we're doing the intervals correctly. Because we know we have to start with pi over 3. We know we have to add pi over 4, 1/4 of our period. And we better end at 4 pi over 3 or we messed up on our fraction math somewhere. So let's get started with that. Pi over 3 plus pi over 4. So putting my pi over 3 in the box so that I know that's going to be something I absolutely have to start at. And then you think for a second, we're talking 12ths again. So this one will need a 4 on the top and the bottom, and this one will need a 3. 4 pi over 12 plus 3 pi over 12 is 7 pi over 12. No reducing that. That is in simplest form. And we already know pi over 4 is the same thing as 3 pi over 12, so we can keep use that as we're thinking through this. So we've got 10 pi over 12 plus another 3 pi over 12, which will be 10 pi over 12, which would reduce to 5 pi over 6. Again, you don't have to reduce these right here, the blue ones that I'm doing. You could wait and reduce when you put it up there on your graph. Add another little pi over 4. Uh-oh, got too close to the edge there. Doesn't like that when I do that. All right, so we had 10 pi over 12 plus another 3 pi over 12. And one more time. So 13 pi over 12 plus 3 pi over 12 is 16 pi over 12, which reduces to, yay us, 4 pi over 3. So this little inequality really helps you know, hey, I didn't flub my fractions. You know, my fractions worked out the way they're supposed to go. So now, look at all those fractions. What are our intervals going to have to be when we actually start our labeling? What's each block going to need to be? Pi over 12 has to be. Got to use that biggest denominator. So let's get them up there. 1 pi over 12, 2 pi over 12, 3 pi over 12, 4 pi over 12 would be the first one we have up here, pi over 3. 5, 6, 7 pi over 12. 8, 9, 10 pi over 12, which is going to be our 5 pi over 6. We can get even less of this one on here. We'll have more to the left this time. So we see the spacing, 1, 2, 3. Actually, mine shifted. 1, 2, 3, 4. When I grabbed the blue. There we go. 5, 6, 7. I go again. 1, 2, 3. I really don't like that I can't see the lines very well. I think that's 4, 5, 6, 7, 8, 9, 10. There we go. So backwards, we can see that we're going to have 3 little blocks. So we should label that pi over 12. Negative 1 pi over 12, negative 2 pi over 12, which would reduce to negative pi over 6. Negative 3, 4, 5 pi over 12. I didn't think it could get any worse than the right side, but I can't see them on the left either. 6, 7, negative 8 pi over 12. Which reduces to negative 2 pi over 3. 9, 10, negative 11 pi over 12. Mine might be a little distorted because I can't see those vertical lines that are up there. And now, did it at a different time in the lab. last graph, but we know that we have an amplitude of 4, so we can put our 1, 2, 3, 4, 5 on here. And this would be where we want to change colors. And we want to make that little helper. We know this is supposed to start at pi over 3. And then we want to think, sine or cosine? Well, this is sine. Sine is Sahala. Sine is axis, high, axis, and then I can't get to the low because I don't have enough low squares over there. But I can definitely follow that pattern backwards. So now I just need to make a nice smooth curve. So I just looked out a minute ago, and you must be feeling pretty good about this because lots of you were done before I even put my graph on there. You feeling okay about phase shift now? Adding that in with A and B? All right, good, because you know that's not the end of it, right? We have one more shift that we have to do, and that's the vertical. We know A, we know B, we know H, but we have to add the vertical. So here it comes. A sine B x minus h, and notice our focus now is on K, and K is the vertical shift. Now this is the one that without that helper line on there, people mess this up all the time. Every once in a while somebody will mess up on the phase shift being moved, but this without a helper on really messes people up. So if it's positive, move it up. Remember, this one's the normal one. It's always x that's the problem, but this is our y. So if positive moves up, if negative moves down, think of moving the x-axis up or down. That is the biggest help right there. Think of moving that x-axis up or down. The graph will now oscillate about the line y equals k. So we call that the sinusoid axis. But just think of it as we're going to move the x-axis up or down to make this work. So the range of a sinusoid in standard transformation form, which is what we're trying to get it to be, that's why we had to do our factoring before, that standard transformation form, is given by, yeah, that always makes people think, oh my gosh, this is complicated. But here's what they're doing. They're saying you're going to change your axis from 0 to k. We already know the amplitude is the height of the graph. So you're going to find k, and you're going to go up, whatever this a value is, and find what your height, the top value for your range would be. And this one gives us our low value. So we've got our k value, and we go a units down. So it's not as difficult as it makes it look, and you don't have to memorize that formula. When you graph it, you're going to know what these are. You could wait until the last step to do the range. You really could. Wouldn't need to do that right away. Now these, pretty obviously, we're not going to fit 2 full periods on here. I don't know why. And this is all the way over. Just this year it started where all these lines disappeared on me, so hopefully mine won't be too distorted up here. Example A, determine amplitude, period, phase shift, and vertical shift. Goodness gracious, all 4. Then find the range and graph each of the following. Well, like I said, you can find the range whenever you want. I will do it beforehand this time, but we can talk about how you could get that anyway. So let's see, amplitude is obviously 4, right there. And we see our B value is a 3 this time. So what we'd want to do, I suppose I shouldn't have skipped writing down the formula there. Do you have that memorized already? 2 pi over B? Okay, good. And I guess it wouldn't matter one way or the other. So I started thinking about my intervals again, And I realize I'm going to need 2 pi over 3 times 1/4. And we could do a little cross-canceling here, cross-reducing. So we're going to have to add pi over 6 quite a few times. And this one has a vertical shift. We better put, since it said phase shift, no phase shift. Not going to have one. There's nothing behind the x that's in the parentheses. But we do have a vertical shift of 2 down. So grab that other color right now so we don't forget this. And we're going to make what will be our new x-axis down here at x equals -2. So I might as well label and get that y-axis taken care of. Well, let's look at starting point and stopping point, which would normally be from 0 to 2 pi, but we have a 3x in there this time. So we'll have to divide all 3 parts of that by 3. There was no phase shift. So it makes sense that it's going to start at 0 and it's going to end at 2 pi over 3 because that was the period. That's what it should do. So now it's all about us finding our values that we need. And I'm going to have to do some spacing here. I need more room. Alrighty. So we're starting at 0. And we found 1/4 of our period before was going to be pi over 6. So we'll add pi over 6. And that will equal pi over 6. And we'll add another pi over 6. And that'll be 2 pi over 6, which is pi over 3. So now we've got our 2 pi over 6 plus another pi over 6, which is 3 pi over 6, which is pi over 2. That didn't look much like a 3. Plus another pi over 6. Well, remember we just had 3 pi over 6, so if we add another pi over 6, we're going to have 4 pi over 6. Which brings us to our 2 pi over 3. But again, what's important about this is that we find that biggest denominator to use. And the biggest denominator that we had here was a 6. So our intervals, our blocks on the graph itself will have to be pi over 6 wide. So I think I'm going to go every 2 spaces will be a pi over 6. So there's 1 pi over 6, 2 pi over 6, which is our pi over 3, 3 pi over 6, pi over 2, 4 pi over 6, 2 pi over 3, 5 pi over 6, and 6 pi over 6, which is 1 pi. And then let's go backwards the little bit that we can here to negative pi over 6. Helper lines. Does this have a phase shift? But it might be a good idea to just go, I know on mine anyway, because mine is not very dark, to just put it right here at 0, so I remember that. But I already had my helper line on there for the vertical shift because I didn't want to risk forgetting that. Now we take a look up there and we see that it's sine. And we realize that sine starts axis. But remember, this is our new x-axis now to make sure that we get that nice vertical shift taken care of. And my amplitude of 4 tells me what I have to do next. So Sahala is axis high. 1, 2, 3, 4. Axis low. Oh, I don't think I went far enough. Should go all the way down 2 to -6 down here, if I can find it. About there, maybe? And then 1 point backwards, doesn't hurt. So the last thing to do for me is range. And like I said, you could have done this before too, because you can think your way through it and say, okay, it's going to be down at -2. If I go down another 4, I'm at -6. It's at -2, but I have to go up 4. That's going to take me to 2. But most people wait until the end, because then you've got it drawn and you can just see it, you know. Then you don't have to think so much through it. Every once in a while they'll ask you that and they'll say without drawing. Well, then yeah, you have to think your way through it. But that adds our K piece. And now for one that has all of it, all of those pieces in there. So y equals 3 sine of the quantity 2x minus pi over 2 minus 1. I want that in that standard form. So I'm going to go ahead and factor that 2 right away. And again, think of it as dividing by 2, which for fractions means multiplying by the reciprocal. So there it is. What's the amplitude? Let's talk about what the period will be. So I'm already thinking about my 1/4 pi. For my little intervals later, that's why I put it in the box, because I use the box to talk through those interval pieces. Phase shift. What's the phase shift and what's the direction? Good. Pi over 4 to the right. One more, we've got the vertical shift. You'll notice with sine and cosine with sinusoids, they don't call them translations anymore. It tends to be shift. You wouldn't be wrong to say translations. So up and down, how much? Where's it going? Yep. All right, so let's think about labeling our y's here. 1 unit down, and then we have to go up and down 3. We're probably going to have to go by 1s again. And let's get that helper on for the vertical. Down 1. Start and stop. We know the start. We know that it's going to start at pi over 4, but we better take a quick peek and figure out how all of that's going to come together. And that was 2x minus pi over 2. So we'll add pi over 2 all over the place. So 2 pi would be 4 pi over 2. I'll write that here just so everybody can see where we got that from. And then we'd add another pi over 2, so that would give us 5 pi over 2. And then multiply everything by a half instead of trying to divide by 2. So from 1 pi over 4 to 5 pi over 4. And we knew we had to start at pi over 4, and we're adding pi over 4. So maybe we don't have to write them down this time. You know, we've got 1 pi over 4, 2 pi over 4, 3 pi over 4. See how that's going to work out nice? No weird denominator. If you want to, it's a great habit to get into. You could still write all that down. So 1 pi over 4, 2 pi over 4 is pi over 2. 3 pi over 4. 4 pi over 4 is 1 pi. 5 pi over 4. 6 pi over 4 would be 3 pi over 2. And 1 backwards, negative pi over 4. Now I'm going to grab my helper line color again, because this one had a phase shift, and I definitely do not want to forget that pi over 4 to the right phase shift. It's like that acts like my new origin now, you know, my 0, 0 again. All right, this is sine. So sine is axis, so we have to remember it's going to start here. Axis, pardon me, high, and this one needed us to go up 3 from our new axis. So our top y value will be a 2. And then axis, low. So negative 1 minus 3 would be at negative 4. Follow the pattern. Oops. Nice smooth curve. Well, that's a lot to keep track of, isn't it, in one graph? And if you're thinking towards the test, you know, you always want to kind of think strategies as you think towards the test. We can't put more than 1 on the test. Think about how long it takes to do all of that. I mean, we've got to test you on all the trig functions, not just sine and cosine. So, you know, you probably see one of these, and it might not have all the A, B, H, K pieces to it. These just, they take a long time to do a good job. So let's look at C. Y equals 3 cosine of 2x minus 1. Here's a question for you. What does that not have? One less thing we have to worry about. Yeah, it doesn't have a phase shift. And since that's the hardest thing, because we have to do all the intervals and everything with that, this one should go much faster. All right, so our amplitude is 3. Period is going to be 2 pi over 2, which is a very lovely 1 pi, so nothing weird going on there. And we said there's no phase shift. The one thing I don't like is that this vertical shift ended up being the exact same one that we just did on the last one. And look at this one. Same thing, you know. We had limited space here to do these, so vertical shift down 1. All right, well, we might as well go by ones again. Don't have a lot of choice. If we're going to fit this on here. And grab a different color and do our helper. amplitude, period, phase shift, vertical shift. We can graph it first before we talk about the range. Although you might have already talked your way through that anyway in your head at this point. So now I started thinking, well, do I have to do anything with this one as far as, because I know it's going to start at 0. This is cosine. And I know that I had pi for my period, which means pi over 4 is what I'm going to use. So you're going to do that in your noggin, or you're going to write them down? 0 plus pi over 4 plus pi over 4 plus pi over 4. Probably not going to write it down, right? Okay. So I'll do every 2 is a pi over 4. No phase shifts. So we're starting at 0. And this is cosine. So cosine starts high. We're going to go to our what we would think of as our new 0, 0, and go up 3 units because that was our amplitude. So high, axis, low, axis, high, axis, low. And then we can give them the old range. Wait a second, did I ever write down the range on? I think I talked about it and didn't do it for the second one. So once you have the graph up, it's just a matter of taking a look and realizing, okay, I was at -4 and +2. And what made me think about that is this one is pretty much the same. So we've got our -4 and our +2. A little faster because of no phase shift. A little bit faster. Now, D looks interesting. X minus pi, huh? Okay, well, A is 1. That's kind of nice. Amplitude is 1. B is 1. So if we take 2 pi times 1/4, that's going to give us pi over 2 for our intervals later. But this one has an interesting phase shift. Pi to the right. Vertical shift, we've dealt with the -1 thing, so vertical shift down 1. Not a big deal. So this one, I've got a vertical shift of 1, but I only have to go up and down 1. So I'm thinking this time I might space them out a little bit. Without the ability to see them. Try that. And put my little helper on there. And start thinking about how this is all going to come together with the horizontal pieces. Well, let's see. 0 is less than or equal to x minus pi. It's less than or equal to 2 pi. So I'd have to add pi to both of these. Or all 3. Well, that's kind of strange. But it makes sense when you think about the fact that we're going to move it over 1 pi. I mean, that's what's going to happen. So we need our little pi over 2 pieces on here. I'm going to go every 2. And I want to put my helper on there for my phase shift. And this one's cosine. So cosine is Kahala, high. So from here I need to go up 1, axis, low, down 1, axis, high, and follow that pattern backwards. And let's put the range down before we flip the page. Lowest value we used. What was it? Lowest Y value. Highest. Does that feel weird? But we moved it down 1, right? That had an amplitude of 1, so it makes sense. Wowzers. Like I said, a lot of graphing today. A lot of graphing. Because we had to put together all of our general transformations that we have with A, B, H, and K. So now, what else could they give us? There could be a negative in there somewhere. There could be a reflection. So what are we going to do? Well, because sine and cosine are special, they do have symmetry. There are some shortcuts here. So when b is a negative value in standard transformation form, use the fact that sine is an odd function and cosine is an even function to simplify the equation prior to graphing. Using these properties will avoid physically reflecting the graphs across the y-axis. So odd function. If you put in a negative for x, then you're going to have a negative when you're done, and that's because it's odd, so it's reflecting rotating 180 degrees about the origin. So what that means is, if you want to move your negative and you don't want to keep it with the x anymore, it's okay to just move it in front of the entire function. And that's a little bit easier to do because then you think of it right away. I've got to reflect over the x-axis. With evens, this is excellent because even functions have symmetry with the y-axis. The negative disappears. So if we have an even function, which is cosine, the negative will be gone. Oh gosh, of course I'm already out of time, right? So today's assignment, nice little worksheet that I gave you in your great big pile of stuff called Graphing Trigonometric Functions. Those of you that are in distance learning, this is already in your black folder, so you can print it out if you don't have it. Black Schoology folder labeled with the date of March 1st, which it happens to be today. So that's today's homework. All right, let me open the door for you. One less handle you have to touch. Thanks for sticking with it today. That's a lot of stuff we covered.